Alright, we're back for one last quick one. Hopefully, it will not take too long. So, here we go. We were just talking about how if you have your home circuit on a parallel circuit, the more and more stuff you plug in on the same circuit reduces the resistance more and more. It's like another branch on the parallel circuit. And so there's more paths for the electrons to go. The resistance is even lower. And we know from the Ohm's law that the current depends on the voltage divided by the resistance. If this number keeps getting smaller and smaller and smaller, then the current gets greater. And if the current gets too great, it can build up heat, it can cause fire. So people used to have a fuse box, and they would have these little round fuses that they would screw in there. They have a little piece of metal going across the top, okay, just kind of like this little metal here in this fuse. This is a fuse you might find like in a power tool or a calculator or something like that. You also have some fuses here that you find in your car, very common. And what happens is if there's too much current, then it melts the metal. If it melts the metal, that breaks the circuit, opens the circuit, and the electricity quits flowing before it causes a major problem. Now, the problem with these were, the round ones, people found that if it would blow a fuse. Well, if you didn't have any more fuses, and you couldn't go to the hardware store, maybe it was a weekend or something and they used to be closed, they would put a penny in the space. And since the penny was copper, it would keep it open, keep the circuit, or close the circuit, and allow electricity to flow through. Unfortunately, whatever was overheating is still going to continue to overheat, and you're kind of missing the whole point of the safety of having a fuse that shuts off, and so it very well might cause a fire or something like that. So eventually they went to something else altogether. So, well, first of all, fuses have to be replaced. Okay, but if you have a circuit breaker, if it gets too much current through here, it creates an electric field, and that electric field flips the switch and turns it off. Now, the nice part about a circuit breaker, which would be in your circuit box or breaker box, is that you can flip the switch back on. All right, and you can see the switches here, like this one's a 20 amp, this one, I can't see for sure how many amps it is. But yeah, there are different ampage, and if you get more than that many amps going through, then it will shut off. A lot of times there's 15 around the house and stuff like that. Okay, and the nice part is, since they don't melt anything, you can just flip the switch and turn them back on, and you don't have to go out and get a fuse to replace it like that. Now the problem is, of course, if you didn't fix whatever, you still have all the stuff plugged in that's overloading the circuit, it's still going to flip back off. So you've got to unplug or fix whatever was causing the problem in the first place. But anyhow, so that's kind of how that works. So a fuse and a circuit breaker both do the same thing. They break the flow of electricity if it gets too much current and gets too hot before it causes worse problems. Now, there's also something you may have seen around your house, which is these, particularly in the bathrooms, for example, anywhere around sinks where there's water, stuff like that. They have these different kind of outlets, okay? And these outlets are called GFCI. GFCI stands for Ground Fault Circuit Interrupter, okay? And basically what they do is, when you have a plug in here, this socket monitors how much electricity is coming out through this prong and how much is coming back, because remember, this whole thing has to be a circuit and goes in a circle path. If it's not the same amount, then it automatically shuts it off and a little button pops off. Then you have to reset it. Okay, so what it's saying is, if there's electricity coming out and then there's less electricity coming back, some of the electricity is leaking out somewhere there. Very often, possibly, if a cord is lying on like a little puddle of water by the sink, it could be leaking electricity, and if it's leaking electricity, it could very well shock you and do serious damage. And so it just shuts itself off, pops the little thing off, if it does not detect the same amount coming back. Now, of course, you turn it back on just like the circuit breaker, unless you fixed the short circuit, or if you had a cord that had a little notch in it, and so water was getting in there and causing problems or something like that. If you don't fix that, it's going to keep flipping right back off again. But that's its job, and usually you're required to have them if an outlet is within so many feet of water of some sort. All right. Now, the this stuff will be for the second quiz, the Don't Be Shocked quiz. All right, so don't be shocked when you see it. And that's pretty much it. The last lecture of the year, I think. So if I don't see you again, have a good summer. And it's been kind of odd this semester, but it's been fun. All right, have a good summer. And if you're a junior, I'll see you again next year.